Welcome everyone. Today we are delving into the fascinating world of computer languages. Computers communicate through various languages, each serving a unique purpose. In this video, we will explore the differences between three key types of computer languages, which are machine language, assembly language, and high-level language. And finally, we will see a comparative table highlighting the key differences between these three levels of computer languages. Now let's unpack each of these categories to understand how they play a crucial role in programming landscape. Before we move on to the core topic, let's understand what is computer languages. Computer languages are also known as programming languages, which are formal systems used to communicate instructions to the computer. Computer languages is a group of instructions which are used to create computer programs. These languages are designed to facilitate the creation of software, which allows programmers to write code that a computer can understand and execute. Each programming language has its own syntax and semantics, which dictates the rules and structure for writing valid instructions. So the computer language serves as a medium for a human to express algorithms and computations to the computer, so that the machines can understand and execute tasks. And these languages come in various types, ranging from the low-level languages like machine language and assembly language, which are closely tied to the computer's hardware, to the high-level languages like Python, Java, and C++, which offer more abstraction and readability. Programmers write code in a chosen programming language, and then this code is translated or interpreted into machine code, which the computer can execute. And these are the key components and aspects that determine how the instructions are written and understood by the computer. The first component is syntax. It is a set of rules that dictates the structure and arrangement of symbols, keywords, and expressions to form a valid instruction. Next, we have semantics. The meaning or the interpretation of the symbols, expressions, and instructions in the programming language is called semantics. It defines how the program behaves when executed. Next, we have data types. Data types are classification of data items. They define the kind of values a variable can hold and the operations that can be performed on those values. Examples include integers, floating point numbers, strings, etc. Moving further, we have control structures. These are the constructs that dictate the flow of program execution. They include loops, conditionals like if-else statement, and branches. The control structures control how and when different parts of the code are executed. And then we have functions or procedures. It is a reusable block of code that performs specific tasks. Functions take input, process it, and return a result, promoting modularity and code organization. And at last, we have libraries and frameworks. These are the collection of pre-written codes, tools, and resources that simplify common tasks and provide ready-made solutions. And they save time and effort in software development. And understanding these components is crucial for a programmer to write effective and efficient code in a programming language. They collectively contribute to the clarity, functionality, and maintainability of a software. So the computer languages are the backbone of software development, allowing programmers to communicate with computers and instruct them to perform various tasks. These languages come in different types. Machine language, which is also called as low-level language. This is the most basic language, consisting of binary code, just zeros and ones. It is directly understood by the computer's hardware. A step up, we have assembly language. Assembly language is a low-level programming language, but it is more than low-level language and less than high-level language. So it is called as intermediate language. In assembly language, data can be represented with the help of mnemonics such as move, add, sub, end, etc. Next up, we have high-level language. High-level language is a computer language which can be understood by the human. Languages like Fortran, C, C++, Java, Python are examples of high-level languages. Now let's understand each language in detail. First up, we have machine language. The machine language stands at the bedrock of computer languages. Machine language is a low-level programming language. Machine language can only be represented by zeros and ones. In this language, the instructions are given in binary format in the form of zeros and ones. Zeros represents the false or off state, whereas ones represents the true or on state. In the intricate dance between man and machine, machine language speaks directly to the hardware using binary language of zeros and ones. A machine language program, also known as machine code, is written using only zeros and ones. This binary language allows the computer to understand instructions, and the data can be represented using the same zeros and ones. And here is the main characteristics of machine language. Binary code and hardware specific. The binary code is made up of zeros and ones, and each sequence signifies a particular operation or a data piece. Secondly, we have hardware specific. The machine language is specially tailored to each machine. That is, machine language is closely tied to a computer's architecture, meaning it is unique and specific to different types of machines. And here is the use cases of machine language. It is used in system programming. So crafting code at most fundamental level is the essential task for building the operating systems and firmware. And next we have hardware interaction. So the machine language communicate directly to the computer central processing unit. Now let's see the difficulties or obstacles associated with the use and understanding of machine language. The first challenge is human readability. Due to its binary nature, machine language is challenging for humans to read and understand. And next we have machine dependency. There is program written in machine language are specific to particular type of computer architecture. Apart from complexities, machine language serves as a foundation upon which the higher level languages are built. It unveils the language of machine, allowing programmers to communicate at the deepest level of computation. Now let's move on and understand the assembly language. Assembly language is used to write programs for microprocessors and other computer devices. Assembly language is also known as symbolic machine language. Symbols are popularly known as mnemonics. Mnemonics is a symbol or a short code that represents the machine language instruction. These mnemonics are designed to be more human readable than raw binary machine code. In assembly language, the mnemonic move is often used to represent the instruction that moves data from one location to another. And here the mnemonic move represents the move instruction. AX is a register where the data is moved, where 1 is the immediate value being moved into the register. In high-level languages like C and C++, developers write code that's abstract and portable, focusing on logic and algorithms without dealing with the low-level hardware details. So for hardware control or performance optimization, programmers may use the assembly language to fine-tune specific section of their code. The assembly language code gets converted into machine language code with the help of an assembler. The assembler is a specific type of translator. The assembly language code is a human-readable code written using mnemonic instructions and symbolic representations, which is specific to particular processor architecture. It is an intermediate level representation between high-level languages and machine code. And we know that machine language code is a binary representation of an instruction that CPU understands. Each assembly language instruction corresponds to a specific pattern of zeros and ones in machine code. And thus the assembler takes the assembly language code and translates into machine code that the computer CPU can directly execute. And here are some popular assemblers used in development of assembly language program. Microsoft Assembler, MASM. Borland Turbo Assembler, TASM. The GNU Assembler, GAS. The choice of assembler often depends on the development environment, platform, and specific requirements of the project. Now let's see some characteristics of assembly language. First, low-level representation. Assembly language is a low-level programming language closely tied to the architecture of a specific computer or microprocessor. And thus it provides direct control over hardware resources, allowing for efficient utilization. Next, the mnemonic codes. We know that assembly language uses mnemonic codes or symbols to represent machine instruction. So it improves code readability and comprehension for programmers compared to raw machine code. Now let's see some use cases of assembly language. First, we have system programming. Assembly language is commonly used for tasks like writing operating system, device drivers, and firmware. So it provides low-level control for managing system resources and interacting with hardware. Next up, we have embedded systems. Assembly language is used in embedded systems to optimize code for specific hardware requirements. Now let's move on and understand the challenges of assembly language. First, it is platform specific because assembly language code is specific to a particular processor architecture, making it non-portable. So it requires rewriting or modifications when transitioning to different platform. And next challenge is complexity. Assembly language programming can be complex and error-prone due to low-level hardware manipulation. So it increases the difficulty of debugging and understanding code, potentially leading to more errors. And these are the characteristics, use cases, and challenges of assembly language. Now let's see the high-level language. A high-level programming language is designed to be easy for humans to read and write. And these languages are closer to human language and more abstract than low-level language. High-level languages provide a level of abstraction that allows programmers to express their ideas in a more natural and concise way compared to low-level languages. Python, Java, JavaScript, Ruby, C# are examples of high-level languages. Now let's see some characteristics of high-level language. First, we have abstraction. High-level languages provide a level of abstraction from the hardware, which allows programmers to focus on problem solving rather than low-level details. So it simplifies code development and promotes readability. And next, we have portability. Code written in high-level language is typically portable across different platforms with minimal modifications. So it enhances code reusability and facilitates cross-platform development. Now let's move on and understand some use cases of high-level language. First, application development. High-level languages are commonly used for developing a wide range of applications from desktop software to web applications. And thus it provides a productive environment for creating complex and feature-rich applications. And next we have system scripting. High-level languages like Perl, Python, and Ruby are often used for system scripting and automation tasks. So system scripting simplifies and accelerates repetitive tasks in system administration and management. Now let's see what are the challenges of high-level languages. First, execution overhead. High-level languages may introduce execution overhead due to additional layers of abstraction and runtime environment. Then what is execution overhead? Execution overhead refers to the additional computational resources and time required during the execution of a program. And the next challenge is learning curve. Learning a high-level language can be tough for beginners because it involves understanding complex concepts. So beginners may find it challenging to understanding things like abstract concepts, syntax rules, and advanced features. And these characteristics, use cases, and challenges highlight the advantages and considerations associated with high-level programming language. And they are designed to provide a balance between abstraction and efficiency, making them suitable for a wide range of applications. Now let's move on and understand the structured comparison chart illustrating distinctions among machine language, assembly language, and high-level language. Now let's discuss the parameters for the three types of languages. The first parameter is basic. The term basic refers to the fundamental nature or core characteristics of each type of language. Basic encompasses the fundamental nature of each type of language and serves as an introductory point for understanding their key attributes. Talking about the high-level language, it is programmer-friendly, easy to understand, so it is widely used. So it offers a heightened level of abstraction, employing a syntax that is more easily understood by humans and distanced from intricate machine-specific details. And next, the assembly language. It serves as a balance between low-level and high-level characteristics commonly utilized in system programming with the capability for controlling specific hardware features. The low-level language is also called machine language, which is designed for machines and tough for humans but straightforward for computer execution. Next parameter is ease of execution. Executing a high-level language is very easy, whereas the assembly language is intermediate level of ease in execution. On the other hand, execution in machine language is challenging. Next up, process of translation. The high-level language requires a compiler or interpreter. So it relies on a compiler or interpreter for execution. The assembly language can be processed in two main ways. It can be either compiled or interpreted. Additionally, it requires an assembler, particularly when dealing with low-level aspects of the code. Whereas machine language requires an assembler, which directly translates the machine language instruction into executable code. Next, efficiency of memory. High-level language uses more memory and it is less efficient in memory utilization. Assembly language uses memory moderately, whereas machine language is highly efficient in memory usage, consuming minimal energy. Next, portability. High-level language is easily portable across different devices. Assembly language can be used on different systems with moderate level of ease. And the machine language is not portable across different devices. And next parameter is comprehensibility or understandability. High-level language is user-friendly, so it is easy to comprehend and learn. The assembly language is balanced between human and machine friendly, which involves some low-level details. Whereas machine language is optimized for machines and it is challenging for humans to grasp and learn. And then we have dependency on machines. The high-level language is independent of machine specifics, whereas assembly language moderately reliant on machines, including some low-level control. And machine language is dependent on machines, which is challenging for non-technical users to comprehend. Next up, we have debugging. High-level language is easy to debug. That is, identifying and fixing error in the code is easy. In assembly language, we have a moderate complexity in debugging, whereas in machine language, it is difficult to debug. And next, we have execution speed. In high-level language, the execution speed is reduced due to the translation process. Assembly language have a moderate speed of execution, which depends on specific language features, whereas the machine language have a faster execution without the need for translation. And next parameter is abstraction. High-level language facilitates greater abstraction. The assembly language is moderately abstract. It finds a middle ground where the language provides a level of control for the programmers to manage the low-level details, while also ensuring that the language is user-friendly and accessible, making it easier to write and understand. Whereas machine language offers very little abstraction. And next, need of hardware knowledge. In high-level language, need of hardware is generally lower because high-level languages are designed to be more abstracted from the underlying hardware, providing portability across different systems and reducing the direct dependence on specific hardware features. In assembly language, there is also a need of hardware, but it might be somewhat abstracted compared to machine language. There is in assembly language, instructions closely match the hardware architecture, and an assembler is required to convert the assembly code into machine code. Whereas in machine language, there is a significant need of hardware. In machine language, instructions directly match the hardware architecture and the computer CPU executes the code. And next we have functionalities or facilities provided. And this parameter refers to the extent of capabilities or functionalities available directly at the hardware level for the given programming language. The high-level language have limited facilities at hardware level because it offers the most abstraction from hardware details and thus provides the limited direct access to low-level facilities. The assembly language provides some facilities for hardware control, but still limited compared to machine language. Whereas the machine language involves fundamental instructions directly linked to the hardware with minimal additional features. And then we have ease of modification, which means how easily and efficiently changes or modifications can be made to a program. In high-level language, modification is difficult because of translation and abstraction. In assembly language, it is moderately easy to modify. Whereas in machine language, it is easy to modify because statements directly map to processor instruction. And here are some examples of high-level language, which includes Perl, BASIC, COBOL, Pascal, and Ruby. And C is often referred as middle-level programming language because it combines the features of both high-level and low-level languages, making it versatile for system programming and application development. And machine language is considered as a low-level programming language. Next, we have syntax. In high-level language, the expressions or instructions are English-like statements that resemble the human-readable English sentences. In assembly language, we use mnemonics. Mnemonics are human-readable symbols and abbreviations for machine code instructions. And these codes are more comprehensible than raw binary instructions. In machine language, the instructions are represented in binary, which consists of sequence of zeros and ones. And next, we have examples for addition in comparative table. See the addition code for high-level language. Result equals num1 plus num2. And this statement adds the value of num1 and num2 and stores the result in result. Now look after the assembly language. Here we have add a comma b. And this statement adds the content of registers a and b. For machine language, let's assume the same example. That is add a comma b. And we have two registers a and b. And we need to add the content of a and b and store the result in a. In machine language, this could be encoded as 0000, 0011, 0100. The opcode for add is 0000. In register A, we have 0011. In register B, we have 0100. This binary code instructs the processor to add the content of register A and register B and store the result in register A. Note that the actual encoding can vary between different machine architecture, so the given is just a simplified example.